I give you Ed McGinnis of Curio Solutions.
One of the last tours at the Department of Energy I had in my 30 years where it was such a humbling experience because I'm not a nuke engineer, I'm not a scientist, but I have worked on the job for 30 years in the Department of Energy. First half of my career in nuclear nonproliferation. In fact, we were the smallest of the 13 Intel community elements at the time. Now I think there are 17. And so I would come over to Sandia and see where it was at, see where the fun was. And so that's when I was first introduced to the SATM and the Davy Crockett and some of those other designs. And then towards the mid of my career at the Department of Energy, I was asked to go over to the other side of the mission space at the Department of Energy and work in the peaceful uses area in the Office of Nuclear Energy and help stand up under that time President Bush's presidential initiative called GNEP, Global Nuclear Energy Partnership. Part of it was predicated on trying to get the U.S. to leapfrog back into the leadership role globally with regards to nuclear energy, but it was really predicated on recycling to solve that nuclear waste ball and chain once and for all so that we can bring in that nuclear era that Weinberg talked about. In fact, that is the cornerstone of our ethos at Curio, and that is we have a nuclear era, the next nuclear era before us that can be driven by inspiration, intellect, innovation. And thank goodness for you all for never ever giving up over the years, because it has been a wilderness at times for nuclear, for innovation, and for certainly trying to realize the full potential of nuclear. And if there's anything that represents the reality that we have not realized the full potential of nuclear energy, is to see where Alvin Weinberg was going, and he had no plans to stop at light water reactors, certainly not. And thorium was the ultimate optimized situation. And so if anything reflects the fact that we have not realized in any way, shape, or form the full potential, but it's not too late, of the U.S. nuclear energy sector and nuclear technology sector, it's thorium. So the good news is we see, and I spent a lot of time in Congress too with members of Congress, senators, and representatives, thorium is back on the radar. Fact is. And thank you all for fighting, never giving up, and passionately staying dedicated to what is an incredible opportunity we have now. Stars in alignment like I've never seen within the Department of Energy, certainly. And so now's the time to realize that next nuclear era per Dr. Weinberg. Let me give you a little context, first of all, on what Curio is all about. Curio is focused on trying to solve one of the greatest ball and chains on the U.S. nuclear energy sector, and that is the nuclear waste, the so-called nuclear waste problem. It's anything but waste when you've only used at most about 4% of the energy value when it comes out after about 4.5 to 5 years out of a nuclear reactor, and then it's at arguably its highest level of radiotoxicity. And so the brilliant idea is, oh, let's just now try and throw it away. No, that doesn't make sense. It is a product of policy, not technical reasons. So now that we see both sides of the political aisle recognizing that nuclear is needed to deal with existential threats. And in my line of work in the Department of Energy, I've always felt like if you're really going to get support from Congress and our policies adjusted, they have to see nuclear as being key elements of dealing with existential threats, whether it is climate, whether it is energy security, whether it is geopolitical, geostrategic, Russia, China, etc. And the fact is, it's all of that, plus jobs, the economy, and other things. Nuclear is in a key position to finally start firing off of all cylinders. But our view is, in Curio, It's not going to happen. We will not realize our full potential if we don't do what we absolutely have the solemn obligation to do for all of the U.S. citizens, all the individuals that use nuclear, paid into the nuclear waste fund, and come up with a legitimate, sensible plan to recycle. That gate must be gone through if we're going to realize the full potential, whether it's thorium or whether it's other advanced reactors and the next generation of fuel cycle. So the bottom line is, what are we dealing with right now? We have over 86,000, now adding 2,000 metric tons a year of stranded used nuclear fuel that by policy is designated as waste right now. I think both political parties are recognizing it's anything but waste. I was speaking with Governor Youngkin for Virginia, who just rolled out his energy plan for 2022. I had met with his team. They're interested not only in nuclear, but they have now built in recycling as a key element of their core plan for nuclear as part of their energy plan. And when I was speaking to him, he beat me to the punch. I thought I was going to have to explain to him the value proposition. He said, "Oh, you're doing nuclear recycling? Can you believe I was told that we're only using 4 to 5% of the energy value in our nation's nuclear spent fuel? That's crazy." So the bottom line is, we're in a unique position to go at this, but we have 86,000 plus metric tons in 75 locations or more around the country stranded right now. The nuclear waste fund is barred from being used for anything but Yucca Mountain. And both political parties, essentially, certainly presidents from both political parties, have said that's unworkable. Consolidated interim storage is an important first step, and kudos to the Department of Energy, but we believe we're going to need more than that. We're talking to states. We know the states are not interested oftentimes, or they're concerned, let's say, in becoming a de facto stranded repository. But when you combine recycling with the proposition of consolidated interim storage and all the economic benefits, tech corridor extraction opportunities, it's a totally different discussion, and we've seen this firsthand. And during the meantime, to throw salt on the wound for the taxpayer, not only have we collected to the tune of, now with interest, over almost $50 billion from ratepayers using electricity from nuclear power plants to pay for the disposition, which we failed to do starting in 1998. I was part of that program, I know. I have tire tracks on my back to talk about it, to attest. So in addition to that nuclear waste fund sitting there and not being used, we're spending almost $1 billion a year in court-assessed fine for failing to pick up the waste and paying compensation to the nuclear utilities for the cost. That is not a sustainable plan, and we need to find a solution. That's the bottom line. One of the key philosophy in our company is that the world has dramatically changed, certainly since Dr. Weinberg. And one way it has changed is that there is an increasingly growing demand that companies and sectors become much more responsible stewards for finite natural resources. When we extract from the ground, we should minimize the impact and absolutely maximize the use of that resource. So nuclear energy, we're extracting uranium from the ground, and we're using 4% of the energy value. Then we're attempting to throw it away, bury it, 100,000 year and even a million year requirement because we're not recycling. That doesn't make sense. We're going into a circular economy world where finite resources is going to become more and more valuable. Maximizing resource utilization will not only be an important thing to do, I believe there's not going to be a choice. It's going to be expected. The nuclear energy sector needs to make dramatic adjustments with the way we manage our fuel cycle in the U.S. for us to meet our full potential. So a circular economy, recycling, maximizing your resource utilization, minimizing waste. and recycling as much as you can. That's what we're about in Curio. The number one oftentimes reason nuclear is opposed in this country, even oftentimes before health concerns. And it's been mentioned, many of the misnomers and false stereotypes of the safety challenges is, what are you going to do with the waste? We're seeing it playing out even today. Those who oppose and organize to oppose nuclear, they're now challenging advanced reactors because where's your plan for the waste? We're the plan. And other companies are working on it at a smaller scale than us. Ours is a national solution, multi-purpose. Well, that's where we are, an open fuel cycle, and that's where we want to go, closed fuel cycle. This is our technology. This is our design. It is about 3 stories high. It's a modular, scalable, largely semi-autonomous, integrated, compact system, tri-vessel system. We have thought long and hard about how to design our chemistry flow sheet, how to design the system, and we know full well what we're trying to do. Many smart, dedicated, and well-resourced groups have attempted to do and not succeeded. As I said, I've been a part of that. Under President Bush, that was the most recent one where there was a real effort to do that. But the good news is we have a lot of experience, lessons learned. And so we know how difficult this is going to be. It's a political, legal issue challenge. It's a regulatory challenge. It's a public perception challenge. And yes, there are technical challenges, but I would say the technical challenges are the least of our challenges. But our technical pathway is intertwined with the public perception and political. I say that because why did President Carter ban recycling or reprocessing? He banned it because of the perceived concern with security. And if we are reprocessing with the technology of Purex, which separates out pure plutonium, has acid-based waste stream challenges, how can we ask other countries that could be would-be proliferating countries not to do it? So it was a lead by example. So the technology is very important and intertwined with the perception. So if you have a technology that doesn't have strong, hardened security built in, it's going to spill over into being a problem in public perception and policy. So our design, number one, never separates out plutonium as a pure stream, period. We always have a commingled with other transuranics and to a certain degree fission products. We will never extract and never have a pure stream. And we do not use an aqueous process. So we are not going to be generating, ironically, a larger stream of liquid-based, acid-based, high-level radioactive waste when we're ironically trying to reduce the amount of high-level waste and recycle. Our facility is compact. It's going to be the size of about a football field. John, like the size of Soldier Field. And this facility is going to consist of about 10 of these modules that I showed you. We're taking the same philosophy that small modular reactors are taking, and that are multiple benefits. You can scale up and not commit all of your capital before the market has materialized. So if we want to have a 2,000 metric ton processing plant a year, or if we want to have 4,000, but we only have orders by the time we build for 2, we only put in 5 modules, not 10. When we get more orders, we put in another module. When we need to do maintenance, we don't shut the whole facility down like they do in La Hague and in Ricasio. We shut down that one module, period. Each one has its hot cell. So we're excited about this design. We're talking to a number of states where this could be. And this facility will be the highest production rate facility recycling in the world. Right now, there's about 2,400 metric tons total capacity when you combine France, Russia, even China's small but growing recycling, reprocessing facilities. About 2,400 metric tons. This plant's going to be 4,000 metric tons a year. High capacity, why? Well, it makes sense. We have the largest fleet in the world. We've always had the largest fleet in the world, which means what? We have the largest stockpile of used nuclear fuel that's being treated as waste. This is a gold mine waiting to be tapped. And our approach is our business is one is to solve the nuclear waste problem by dispositioning, taking title once and for all of this material, dramatically reducing by 96 or so % in our calculation with our flow sheet of the high-level radioactive material. We have a good plan to deal with medium, intermediate, and low level. And so we believe, and we're going to be focused on not only dispositioning, solving that, but the bigger business, frankly, is going to be product extraction. We're going to be extracting every isotope possible that has market value. By doing that, you get a win-win. We're going to be extracting certainly UF6 for feedstock for LEU, feedstock for HALEU. In fact, a 4,000 metric ton facility will literally produce 40% approximately of our entire U.S. annual nuclear fuel requirement. That complements the uranium mining industry. It's not a competitor, because if we unlock and if we solve the waste problem, our nuclear sector is going to take off. That's our view. So let's stop diving for scraps in a rapidly declining nuclear sector in the U.S., and let's go at it with innovation, unlock it, have the pie grow, and there's going to be plenty for all of us, including the uranium mining and the traditional enrichment sector pathway. So this, again, just reinforces the size differential. The recycling, reprocessing facilities around the world are sizes of small cities, and they're all run by government-owned companies. We are private, and we are absolutely wired and focused on minimizing overhead, maximizing value, and maximizing efficiency. So I'm just going to cover a few other things and then open it up to questions. But I wanted you all to hear about what went into our design. And let me just say right now, we are in the process. We have 4 national labs in partnership with us, including Sandia National Lab, and Idaho National Lab, Pacific Northwest National Lab, and Oak Ridge National Lab. We're engaging with others like Argonne. And we are focused on lessons learned. Our design system is, again, based on, well, not again, I would say, this is such a hard thing we're doing. It all has to be about de-risking. We have to de-risk in our public engagement and try and change that paradigm to it's not waste. It's incredible. It's an incredible resource for medical, space-based power sources, clean nuclear fuel, industry, other applications, number one. So it is an incredible resource. We have to de-risk from a technical perspective and prove out an acceptable flow sheet and technology process that is acceptable to our priorities in our country, such as not separating out plutonium and not generating more waste through aqueous acid-based process. So we are taking the lessons learned and building them in. So as I said, modular, compact, and scalable, built in by design security, and maximizing product revenue. So here are our key chemistry stages for our novel, what's called NuCycle process, trademarked and under patent file. All 3 of these chemistry areas are well known at the various national labs to some degree. We are not looking to reinvent the wheel. We want to use proven technology, not unlike SpaceX. I don't think that Elon Musk and SpaceX developed many brand new alloys or technologies. Off the shelf, it's the unique application, business plan, and operational plan that's going to make the difference. That's how we're approaching it. So first and foremost, we're maxing out the dry process through heat, through pyrochemistry, And the first vessel I showed you, or the three, the head-in process, that will be a voloxidation deox process, as we've referred to it in shorthand, where we will achieve the decladding from the fuel pellets, and then with the heat and the oxidation, it will be pulverized and fall to the bottom, gravity fed in the first vessel, and then the pulverized U308 will then flow into the second vessel, and then we will do a fluorination process. We will fluorinate it for a number of reasons, including extracting products. UF6, in fact, in the previous process, we'll be extracting, in the pyrochemistry or in the deox, we'll be extracting other isotopes. We're going to be extracting isotopes throughout because that's our main priority. We'll extract krypton-85. That's in strong need for many different industrial, medical, and other needs. Fluorination, we will continue to extract other isotopes and elements. And then finally, the third stage is a electrowinning process, an electroreductive extraction process. And we will, at that stage, have molten salt injected in it. But molten salt is much more manageable, in our view, and can be recycled and reused effectively. The last stage is where we extract the transuranic-based fuel, what we call true fuel. That fuel will be extracted and it can be used at large scale, for molten salt reactors, sodium-cooled fast reactors, and others. The purpose of this design is to be multi-purpose, multi-application oriented. It could be used for light water reactor, BWR, PWR. We can recycle significant types of advanced reactor fuels, sodium-cooled fast reactors, as I said, molten salt, and even others. We can even do other things with this system. Our plan time-wise is to do a full flow sheet integrated lab scale demonstration within the next 3 years with the 4 national labs. We have a number of offtake partners. We have an agreement with one U.S. utility already saying they want to recycle the used nuclear fuel sitting in their dry casks, and they want us to recycle it and turn it back into fuel, getting into that circular economy. We have a number of other off-takers. We have advanced battery design, very exciting new field, taking strontium-90 and putting them in the synthetically encased diamonds, for example, batteries that could last 200 years. You could potentially throw away your phone, you're keeping your battery. The battery will probably outlive us. It's a disruptive approach using innovatively isotopes that we heretofore treated as waste. So next 3 years demonstrate that. By 2028, our first 100 to 400 metric ton pilot facility. We're talking to labs as a potential venue for that, such as Idaho National Lab. We met with the governor, and we're meeting with others to consider where that would be optimized. And then by the mid-2030s, in about 13 years, we plan to have our nation's first full-scale 400,000 metric ton or so recycling facility. Wherever that facility goes, in whatever state, it'll make that state the single largest clean nuclear fuel production supplier in the country and likely the world. So this just reinforces the scale of our project extraction, whether it's for 700 metric tons equivalent for LEU, ultimately 120, transuranic-based fuel, 40 metric tons. We would be extracting significant amounts of 237, neptunium-237, if the market demands, so you can then have the stream for plutonium-238, nuclear batteries, etc. This is the vision. We take a holistic vision. We're about checking all the boxes, dealing with all the issues, including low-level waste, intermediate, and high-level. We see this as the future. It's going to unlock the potential for the U.S. nuclear sector, and frankly, I believe in for thorium. Here is our executive team, and we put together a very strong advisory board, many of those with a lot of experience in the industry. So at the end of the day, a rising tide lifts all ships, and we want to be that rising tide. So thank you very much. Any questions?
Super exciting.
So, quick question, is the intention for these to be installed alongside existing nuclear reactors or as a replacement for new installations? I mean, what is the intention?
The answer is no. In part because of the scale and the economics. Our view is the best way to really get a recycling facility in an optimized economic situation, you're going to need scale. And we have this like no other in the world with 86,000 metric tons. It's a unique advantage because it's not waste. But we would see a consolidation. We would envision our facility, it could be 2,000 metric ton facilities, one East Coast, one West Coast. It could be maybe more than two. But certainly for our view, it would not be attempting to set up and get siting and do all the capital expenditure at every location where there's a reactor. There are companies that are looking at that, and good on them. But those are companies that are generally offering a solution for the fuel coming out of their reactors. Our company is focused on a national solution, and so our facility would receive the fuel, receive title, and then in a very mass processing scale, but compact and integrated process there. And we would envision the facility to be really the basis of a tech corridor that would grow around it. Because think about it, we would have feedstock coming out for fuel, LEU, HALEU, for advanced reactors, for space-based power sources, battery, etc. All these companies would likely come and set up shop around there so they can extract there and do production. Our facility would have about 3,000 employees, well-paid generational jobs, mostly trades, and then probably twice that for the downstream economy. I know I'm killing John, he's about to cut me off.
Hi, Alfred Parrish, no particular qualifications.
I haven't heard that degree. Where is that from?
France is, as we all know, is currently the leader on this, and they take a lot of waste from other countries, so I just wanted to ask, do you have plans for international shipments? Like, are you thinking that far ahead?
Well, first of all, to clarify, I'm very familiar with the French model, and they actually will take the waste, they use nuclear fuel, but under one condition, that that country agrees to take back the fission products and the remaining waste once they extract the plutonium and the uranium. That's what they do. It was the agreement with the UAE, or the offer. But other countries that have received fuel, it's by law, there's no choice that CEA has and the companies. But they do, and they are a leader. They are the leader as far as capacity and reprocessing. They use PRX, so they do have an international business, but it is not a complete take back. They do enter into agreements where the remaining waste has to go back to that country, and they have to agree to that, or they can't sell the fuel by French law. For Curio, I would say our focus, our priority is right now in the United States. That's number one right now. In the future, we will see. But this is a collaborative partnership. Wherever we site our facility, the most important voices are going to be those that live in the area and our partners in the state and local communities, among others. So that's something that will be looked at in the future. But right now, we have the largest market opportunity in the world because we have the largest stocks of so-called waste ready to be turned into valuable societal products. And so we have right now no need to look anywhere outside our borders. Right now we're focused on getting the next nuclear era in place, as Dr. Weinberg said.
When I'm attending like a college campus lecture, guest lecture, and it's all about nuclear power, energy, and whatnot, and they bring up, well, what about the waste and everything? I can say yes or no. I can say, they'll look at Curio. They've got the answer to nuclear waste.
Yes, we do, and we have a lot of information on the website. We we're investing in the next generation. We have a lot of young engineers. We brought in an intern from a university in Colorado, and it's remarkable how excited they are. And I think that they really appreciate how profoundly important this is. If you believe in nuclear energy, it's really hard. It's really hard to see us getting that next nuclear era, transitioning, if we can't solve something that is so intuitively obvious as our used nuclear fuel.
Very important what you're doing. Very happy to see this. I'm just curious, does your process, do you require external power inputs? Do you generate your own process heat in your plant? Or no ideas about putting some sort of small reactor to generate your own power in your facilities?
Yeah, our facility, unlike a nuclear reactor, is not going to require anything that is extraordinary as far as power. Our power can come right off the grid. And the real challenge or the real focus for our facility is developing components that can perform the maximum time possible in a hostile environment, physics-wise. It's not just the salt, it's the processing and it's the technologies, and doing it in a way where it can be a facility that can be operated 50 years or more. That's why modular is really important, because we can more easily access and switch out. And each module allows us greater access to all the components and sensors that need to be pulled out. But power supply, I think that is a very manageable issue off the grid. The big challenge, again, is really getting an optimized flow sheet with components that can be optimized for processing with minimum mechanical intervention and minimum repair.
All right, one more question, and this is Jim Conca.
So I envision Curio set up next to a centralized interfered facility set up next to it.
Well said. I should have asked you to come up here. No,
Well, you know, Jim used to run the whip.
Yeah.
Really, I hadn't heard of you, Jim. No, you know you well, Jim, and I appreciate all you've done over the years. I would just say that consolidated energy storage, as I said in the beginning, is a very important step. Secretary Granholm, Assistant Secretary Katie Huff, and others deserve credit for trying to restart a solution pathway. And we believe we can be a very important element to that. And we're already seeing it happening. As a private company, it's easier for us in some ways to just go straight to a Capitol, speak to the governor, speak to the legislature, and we've done that. And we've seen it. The consolidated energy storage, it's a very tough discussion to have because of yucca that looms the shadow. But if you introduce what I just said, in a credible way with due diligence, not blowing smoke, it's due diligence. This is proven technology, chemistry, and you show them what we can do with this. Like Governor Youngkin said, oh, we're only using 4 or 5%? So you don't have to be a physicist or a nuclear engineer to understand the value proposition for that. So matched up with the consolidated energy storage, that could be optimal.